Hey there, science students. It's Mr. Greenwalt back with another screencast. Today we'll talk a little bit about temperature and humidity. Now we'll go a little bit further in class, a little more detail. Got some demonstrations and probably some clips to show you. But for now, let's get some definitions and explanations out of the way, save ourselves a little bit of time in class. So here we go. All right, number one, temperature is a measure of how fast molecules are moving. Now when we think of temperature versus heat, we oftentimes think that they're one and the same. Now, they're both very closely related, but by definition, temperature is simply how quickly are molecules moving. Now, it's a little bit different when we're talking about air molecules, molecules of water, or let's say molecules that are a part of this solid tabletop. Okay, they move a little bit differently, but molecules are always moving. If it's part of a solid, the molecules are just vibrating. If we talk about gases, a molecule of air here could move over here without much problem. However, in a solid, a molecule of the table here isn't going to migrate to this side of the table. It'll just simply vibrate. With a liquid, it's a little bit somewhere in between, as is the case with water. Anyway, so temperature is the speed at which molecules are moving, and the faster those molecules are moving, the higher the measured temperature. Let me go ahead and make myself a little bit larger here so you can see the thermometer that I'm holding in front of the camera. So here we have a thermometer, and hopefully you can see that the temperature that it is measuring, let me get the angle right, there you go. The temperature is measuring just above 20 degrees, you can see there. Now, let me grab my heat source. Yes, this is a flame. So, allow me to go ahead and apply some heat, flame, to the thermometer. Now, what's happening here as I hold the thermometer over the flame is that it's causing the alcohol, which is the blue liquid in the thermometer, to heat up. Now, as the blue liquid, the alcohol heats up, it's going to be moving faster. Now, because the bulb is so small, the alcohol has difficulty moving within that little bulb, so it has only one place to go, up the thermometer. So when we apply heat, we measure a higher temperature because the alcohol in the thermometer has sped up. So now, if you'll notice, just a few seconds of holding it over the thermometer, we're now measuring a temperature, if you can see the little blue liquid in there, over 80 degrees Celsius. So you can see by applying a heat source, energy, to the thermometer, we're observing a raise in the temperature. Now, go back to where you belong in the corner. Now, heat, again, is just simply energy. So remember, I added the heat source, which was the flame, energy, to the thermometer. The alcohol began moving faster, and as a result, we measured a higher temperature. Now, in terms of energy being transferred, energy always moves from an area of high temperature to an area of low temperature. So energy will only be transferred in the case that there's a difference in temperature. A good example is when your hand grabs a cold can of soda. My hand feels cold because the can of soda is cold, my hand feels cold because my hand had a higher temperature than the can of soda. So heat was drawn away from my hand to the can of soda. Thus, my hand feels cooler and the can of soda begins to get warmer because there is a transfer of heat from my higher temperature hand to the lower temperature soda. Now, when we talk about measuring temperature, there are, of course, two scales that you're very familiar with. The first, of course, is Fahrenheit. Now, it's based on the freezing and boiling point of water. So in terms of Fahrenheit, water freezes at 32 degrees. It boils at 212 degrees. In terms of Celsius, the freezing point of water is 0 degrees and the boiling point is 100 degrees. Now, you tell me which one makes sense. Now, both scales were begun with the freezing point and the boiling point of water ended with. However, the Celsius scale actually makes a little bit more sense if you think about it. What Celsius did, which is the name of the professor, he used a thermometer. He marked the point at which the liquid in the thermometer was at its lowest, which was the freezing point of water. He made a line there. Then he heated that water up and marked the highest point at which the liquid rose in the thermometer, which marked the point at which the water boiled. He marked that at 100. And then all he did was make even increments, boom, 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 from 100 back down to 0, and that's how we got the temperature scale of Celsius. Fahrenheit scale, although we're more familiar with it, is a little more confusing. Now to the scale we use in science, and you saw this come up in the astronomy unit. Kelvin is a scale developed by Lord Kelvin, a scientist in the 1800s, and he actually came up with a theoretical temperature. He thought that if you could cool a substance down Remember, what would happen to the speed of molecules if we remove the heat and cool it down? That's right, the molecules should slow down gradually. So theoretically, Kelvin thought, well, if we could remove all the heat, molecules would slow down and slow down and slow down, and eventually, if something continuously slows down, it will stop. So Lord Kelvin theorized that if all molecules stop moving, we've removed all of the heat from the substance, and that is what he called absolute zero. As a matter of fact, even the vastness of outer space measures a temperature of about 14 degrees Kelvin, so even the vastness of outer space is not the coldest cold that can exist. Now we get to something called the dew point, but before we get to that, we need to remind you of what the words evaporation and condensation mean. Evaporation is where liquid water turns from a liquid to a gas. And this is how water gets mixed into the atmosphere through the process of evaporation. However, when you cool that water vapor down enough, it can condense, turn back from a gas to a liquid. You've seen this happen all the time surrounding a cold glass of water. We say that the glass is sweating, right? Well, in actuality, what's happening is the water molecules in the air cool down enough so that they attach to the glass in liquid form. That is condensation. Well, the dew point temperature is the temperature when that water vapor in the air condenses back into liquid droplets. Now we call it the dew point temperature, and you know what dew is. It's the water that's on our grass in the morning. Well, the morning hours are the coldest temperatures during the day, and so that's when the air temperature has cooled down enough for the gaseous water vapor to turn back into liquid droplets, and it attaches to the closest surface, usually blades of grass, or perhaps a windshield, or in the case of a very cold glass of water, on the edge of a glass of water. So remember this, dew point temperature is always colder than the air temperature because air must always be cooled to condense. Let me ask you this question. Have you ever had condensation or sweat form around a warm glass of water? No, you haven't. Lastly, humidity. There's always some water vapor in the atmosphere. However, the amount that the air can hold depends on temperature. So when we measure humidity, we're simply measuring how much water vapor is present in what otherwise would be dry air. Again, the amount of water vapor that the air can hold depends on temperature. So let me say it to you like this. You may notice that during the winter months, you feel a lot drier. You get dry, flaky skin, your lips become chapped. That's because colder air cannot hold as much water as warmer air. So the atmosphere is capable of being more humid in the summer than it is in the winter. We'll take it from there in class at a later date. Thank you very much, and please remember to answer the questions in the Google form.